Okay, here we have a double slit problem. It's a very straightforward double slit problem. Now look, there's this center line between the slits. I'm going to draw in this center line, and that's where distances gets measured from. So what you get on the screen here is you get bright, dark, right? You get this pattern, and then the same pattern going down. You get dark, bright, right? And then the fringe order. So this bright and dark, they're referred to as fringes. So this central bright is referred to as the 0th order maximum. Sometimes they call the bright spots maximums, the dark spots minimums. But this is fringe order 0. Then the darks, you have two 0th order darks. That's m equals 0. Okay, so this guy here would be first order bright. This guy here would be first order dark, right? Now, the equations that you're using, you're going d sine theta equals either, it's going to be m lambda. That's for a bright. If it's a dark, then this becomes m plus 1/2 lambda. Does that make sense? So if it's bright, then it's m lambda. If it's dark, it's m plus 1/2. If you're confused, watch my lecture from yesterday. Okay? Then the other equation is this. Y equals lambda L over D. Wait, is that the equation? Hold on. Hold it. Yes. And then for brights, it's going to be m. If you're talking about a dark, it's m plus 1/2. Okay, so let's just leave this for the darks because that's what they're asking about. Now, what's the y? This y value here is the distance off the center line. So say, for example, they want you to calculate where the first order bright is. So here's the first order bright right there. So that would be the y measured off this center line. You just plug into that equation. Okay, so let's do the problem now. First question. Calculate the frequency of the light. Oh my gosh, easy. So how do you do part A? Part A, we're using the wave equation. Velocity is wavelength times frequency. We happen to know the speed of light, right, in a vacuum. Well, here we can assume it's air because they don't say otherwise. What does this V become? It becomes C, right? So frequency is going to be C over lambda. C is a constant, 3 times 10 to the 8th. And you just got to be careful here. This wavelength, what do you got to be careful about? Nanometers. That's 10 to the negative 9. So this is 550 times 10 to the negative 9 meters. The meters cancel, and you get a frequency of, rounding to 10th place, 5.5 times 10 to the 14th hertz. That's the frequency. Now, part B. Calculate the distance between two adjacent dark fringes. How do we do two adjacent dark fringes? Well, here's what I'm going to do, guys. Here's what I'm going to do. I think this is a rather nice way to look at it. I'm going to go like this, okay? I'm going to get the distance from this center line, right, from here up to the first dark, right? I'm going to get that distance. So then what would be the distance between two darks? Because look, this pattern going down is the same thing. You guys follow what I'm saying? I'm going to calculate this y right here, the distance from the center line up to the 0th order dark, and then so we'll just double it. So the equation is going to be this. We take this equation here, y equals, we're going to go lambda L. We're talking about a dark fringe, so it's m plus 1/2 over d. So the lambda is 550 times 10 to the negative 9th meters. L is given 2.2 meters. What's this m right here? 0, right? I'm going to right there. That's m equals 0. So that's just going to be a 1/2. And then d is also given. Where's that? 1.8 times 10 to the negative 5. So we get a y value of 0.0336, right? But that's the distance from our 0th order bright to the 0th order dark. But what they want is they want the distance between two adjacent dark fringes. So what we got to do is double that. So the correct answer is 0.067. That's the answer to part B. Now, part C. What do they think we are? Idiots? They think we're stupid? Hey, what do we know about the frequency of light? It stays constant. The frequency is the same. So the answer to part C is the same answer that we got in part A, which was what? 5.5 times 10 to the 14. Now, we're almost done. Don't get up. D. Does the distance between the dark fringes increase, decrease, or remain the same? Oh, you know what? Well, what happened here? Well, they tell us right here. The entire apparatus is now submerged in a transparent fluid with an index of refraction of 1.4. Hey, man, what's going to happen to the speed of the light in this transparent fluid? Does the speed of the light go up or down? Down, because, right, n equals c over v. If n goes up, then v goes down. Well, look, what caused the v to go down? Well, what's the wave equation? Velocity is wavelength times frequency. Frequency is constant. That doesn't change. So if the velocity goes down, what must have caused that? The wavelength. Now come over here. Look at this equation. If the wavelength goes down, what happens to y? It gets smaller. So the answer is decrease.